Hello, everyone. This is part 2 for week number 8. And in this particular screencast, we're exploring single subject designs. So we've explored a variety of things to this point, including observational epi and descriptive epi. We looked at randomized controlled trials and quasi-experimental, and now on the experimental side, we're exploring the single case design. So why single subject designs? The demands of traditional experimental methods are often seen as barriers to clinical inquiry for several reasons. Because of their rigorous structure, experiments require control groups and large numbers of homogeneous subjects, often unavailable in clinical settings. Group studies typically take measurements at only 2 or 3 points in time, potentially missing variations in response that occur over time. The experimental model deals with group averages and generalizations across individuals, which may not allow the researcher to differentiate characteristics of those patients who respond favorably to treatment from those who do not. Although generalizations are important for explaining behavioral phenomena, clinicians understand that group performance is relevant only if it can be used to understand and predict individual performance. So consider a study that was done to determine the occurrence of stuttering, if the occurrence of stuttering would be different if adults read aloud as usual or as fast as possible. A group of 20 adults was tested, and no significant difference was seen between the two conditions based on a comparison of means. However, a closer look at individual results showed that 8 subjects actually decreased their frequency of stuttering, 1 didn't change, and 11 demonstrated an increase during the faster speaking condition. So the group analysis obscured these individual variations. These results could mean that there is no consistent effect, but they also point to specific subject characteristics that account for differences. So single subject designs provide an alternate approach that allows us to draw conclusions about the effects of treatment based on the responses of a single patient under controlled conditions. These designs provide a clinically viable, controlled experimental approach to the study of a single case or several subjects, and the flexibility to observe change under ongoing treatment conditions. The independent variable is the intervention. The dependent variable is the patient response, defined as target behavior that is observable, quantifiable, and a valid indicator of treatment effectiveness. Single subject designs can be used to study comparisons between several treatments, between components of treatments, or between treatment and no treatment conditions. There are 2 core elements: the repeated measurement and the design phases. And again, it's important to highlight that single subject designs are not case studies. So what is repeated measurement? Single subject designs involve the systematic collection of repeated measurements of a behavioral response over time, usually at frequent and regular intervals, such as at each treatment session, which may be more than once a day, each day, or once a week. These repeated assessments are required to observe trends and patterns in the data and to evaluate variability of the behavioral response over time. This type of variability is obscured in group studies when behavior is measured only before and after treatment. The advantage of repeated assessment is that the researcher can observe response patterns and modify the design as the study progresses to obtain the most meaningful outcome. The second core element of a single subject design is the delineation of at least 2 testing periods. These are the baseline phase and the intervention phase. The target behavior is measured repeatedly across both baseline and intervention phases. The baseline phase provides information about responses during a period of no treatment or during a control condition. This initial observation period reflects the natural state of the target behavior over time in the absence of the independent variable. The assumption is that baseline data reflect the ongoing effects of background variables, these being daily activities, other treatments, or personal characteristics. When treatment is initiated, changes from baseline to the intervention phase should be attributable to the intervention. Therefore, baseline data provide a standard of comparison for evaluating the potential cause and effect relationship between the intervention and target behavior. So the design phases are traditionally plotted on a line graph, with magnitude of the target behavior along the y-axis and time along the x-axis. The baseline period is noted by the letter A, and the intervention period is noted by the letter B. This would also be known as an A-B design. Now, looking at single subject design baseline characteristics, we're curious about stability and trends. These characteristics, stability, this reflects the consistency of response over time, and we can see that shown in A very nicely. And then trend, or the slope, which shows the rate of change in the behavior. So let's explore the different characteristics shown here at baseline. Now, why is this important? Because we want to be able to determine if there is an effect to the treatment that we prescribe in this A-B type of scenario. Now, A is the most desirable baseline pattern. There's a constant level of behavior with minimal variability. So the target behavior is not changing, whatever our outcome of interest is. Now, because of this, changes that are observed after the intervention is introduced can be confidently attributed to that intervention. Now let's take a look at B. This is a problem for interpretation. So it's going up, it's going down. It can be hard then to interpret what would happen if we applied the intervention. So what's recommended is you continue to collect baseline data until some stability is created. C is an accelerating baseline and D is a decelerating baseline. These indicate changes in the target behavior that's occurring without intervention. Either type may represent improvement or deterioration. Now, ideally, A is what you want, but let's say C was an increasing situation, and you assumed that, or you hypothesized that your treatment would reverse that. Well, that might be appropriate. Same thing with D. It might be appropriate if you think your treatment's going to reverse that decline. How long should phases be? There is some flexibility here. Generally desirable to use a relatively equal phase length. Researchers may preset intervals of 1 week for each phase. But as I said before, there is some flexibility, and considerations that the researcher will think about include things like the patient, the type of treatment, and the expected rate of change of the target behavior. So what is essential is that the period of time is of sufficient duration to capture the potential changes. And it is recommended a minimum of 3 to 4 repeated measures during a phase. Target behavior is that patient response to the independent variable. Measurements may deal with overt motor behaviors, such as functional performance, range of motion, strength, gait characteristics, pain, or a variety of things. Another example, one can assess physiological variables, for example, blood pressure, or exercise responses, or heart rate, or any of the typical vital signs that you might utilize in regular clinical practice. Now, when measuring the target behavior, we want to quantify the response to the independent variable. Most common techniques looking at frequency, duration, and magnitude. Frequency count, this indicates the number of occurrences of the behavior within a fixed time interval or number of trials. For example, counting the number of times a patient loses balance or the number of times a patient demonstrates a gait deviation. Frequency is expressed as a percentage or rates. Duration. Target behaviors can also be evaluated according to how long they last. Duration can be measured either as a cumulative total duration of a behavior during a treatment session or as the duration of each individual occurrence of the behavior. For example, we can measure how long a patient stays in a balanced standing posture within a single trial or over a treatment session, or we can time how long it takes for a patient to complete a specific functional task. Magnitude, that being the change in size. For example, using a force plate to assess the effect of balance training on movement of the center of pressure and time to stabilization in children with CP. So an A-B design just has two phases. And I think when I think about A-B designs, I think the easiest way to think about them is how a medication might make that change. So we've got the baseline period where there's no treatment, and then we give the medication, and then we see the change that occurs. So here's an A-B design. There's a stable response at the beginning, and then we see that there was an application of occupational therapy services. And as those occupational therapy services were provided, we see a rise in the language comprehension skills in the subject. Now, there can be design limitations to an A-B, so other events, competing hypotheses, may account for the improvement in that outcome. So in this particular case, there could be other things that accounted for the improvement in the language comprehensive skills. For example, in this particular example, there was individualized speech therapy that started at point D, and there was developmental therapy that was started at point F. So we're observing changes, but we may not be able to attribute all of them to the occupational therapy. Now, to strengthen the control of this design, we would probably want to try to limit other things. So, for example, if we think about the medication example, making sure that there's nothing else that that individual is starting at that point in time other than the medication. Now, in ABA design, this replicates one baseline phase following an intervention. The premise of this design lies in its ability to show that behavioral changes are evident only in the presence of the intervention. If changes in the target behavior are not maintained during the second baseline period, one can logically conclude that the treatment was the factor causing the changes observed during the intervention phase. So here's a particular example of an ABA study design. Researchers studied the effect of using visual cues during gait training in an individual with Parkinson's disease. They assessed gait speed as the subject walked a distance of 10 meters as many times as she could in 30 minutes. The subject was seen 3 times a week. The 4-week baseline phase included gait training without cues. During the intervention phase, visual cues were placed on the floor along the walkway. After 4 weeks of intervention, cues were removed and gait parameters were measured to assess retention of gait training. So what's shown in the figure there is there was stability in the baseline scores. Clear improvement was seen in the intervention phase. The increase in gait speed was somewhat variable, but maintained an increasing trend. Then there was a decrement in performance when the intervention was removed. So we can see that drop between B and A2. But interestingly, and this is what's kind of challenging about some of these things, was there a learning effect? And it appears that improvements were seen again over time. Now, how does a medication study work? Let's make something up. Somebody has a fast heart rate. You measure that in A1. You give them a medication. It decreases in B. And then you remove the medication and the heart rate increases again. Very simple ABA design, showing that the medication was necessary for the reduction in one's excessively fast heart rate. Now, a problem with ABA, the behavior again must be reversible. So that gets into that example of my heart rate one. Oftentimes, though, a behavior is not reversible. Any response that's learned or that creates permanent change will not show a decrement when the treatment is withdrawn. And here's an example. A study was done to determine if manual physical therapy, therapeutic exercise, and patient education would be an effective strategy to reduce pain for a patient with disc displacement without reduction of both TMJ joints. Pain was measured using a visual analog scale over 15 visits. Pain was stable during the first baseline period in A1, then showed a decline during the intervention period during B. And even when the intervention was decreased or taken away, there was the continued decline occurring in the second baseline phase. The pain level was clearly decreasing starting at the point of intervention. The treatment was effective, and even removing the treatment did not then cause a reversal. There are ABAB designs. Experimental control and clinical relevance can be strengthened through this design. Major advantages: provides two opportunities to evaluate the effects of an intervention. If effects can be replicated during two separate intervention phases, controlling for internal validity, the evidence is quite strong that behavioral change was directly related to the treatment. And so here we see a picture of ABA, and I'm not going to talk about or discuss this particular scenario here, but I think if we think about ABA, again, you could do that same heart rate medication example. Fast heart rate, take the medication, slows the heart rate. Take away the medication, fast heart rate returns, then give the medication again, and if it slows the heart rate, you have observed the behavior change you wanted to observe. Now, limitations: the behaviors must be reversible to see treatments. If, however, the target behavior does not revert to original baseline values but stays level during the second baseline phase, the ABA strategy still makes it possible to demonstrate changes if there's further improvement during the second intervention phase. Now, will you be coming across ABAB studies? Probably not, unless you're doing something that's medication related. I would imagine the majority of you, from what I'm recalling, you're probably not going to have any ABAB studies within your within the X number of studies that you find. If you do, I'd be surprised, but if you do, these are experimental studies. They have value to them. And if you do find them, we can talk more about them and how to include them at that time.